Let us start with third chapter in third module, data warehouse. What is data warehousing? What is data warehousing? A data warehouse is an organized collection of integrated, subject-oriented databases designed to support functions. A data warehouse is organized at a right level of granularity to provide clean enterprise-wide data in a standardized format for reporting, query, and analysis. It is physically and functionally separate from operational and transactional databases. Now, why data warehouse is required? Data warehouse supports business reporting and data mining activities. It can facilitate distributed access to up-to-date business knowledge for department and functions, thus improving the business efficiency and customer service. It also enables a consolidated view of corporate data that is cleaned and organized. Let us go to the next topic, that is the characteristics of data warehouse or design considerations for data warehouse. The main objective of a data warehouse is to provide business knowledge to support decision making. For a data warehouse to serve its objective, it should be aligned around those decisions that is easy to access and up to date. There are few design considerations for data warehouse. The first characteristics is subject oriented. An effective data warehouse should be designed around a subject domain which can help to solve a certain category of problems. Second characteristics is a data warehouse must be integrated. A data warehouse should include data from different functions that can shed the light on a particular subject area. Thus, the organization can benefit from such analysis. The third characteristics or design consideration is a data warehouse must be time variant, or it should have the time series data. Yes, the third characteristic is the data warehouse must be time variant. The data in data warehouse should grow at a daily or other chosen interval. That is, a data warehouse must have the data from the past or historic data to the present data. Fourth characteristic is a data warehouse is non-volatile. A data warehouse should be persistent. That is, it should not be created only for a particular operational databases. A volatile data can be erased. So a non-volatile data is nothing but it should have a strong backup, and it can be accessed whenever it is required. The fifth characteristic is summarized. A data warehouse contains rolled up data at a right level for queries and analysis. So a data warehouse is represented by using multi-dimensional model which can be helpful for analysis. The sixth characteristic is not normalized. A data warehouse is often used a star schema, which is a rectangular central table that is surrounded by different lookup tables. Now this particular table can enhance the speed of execution of queries. The seventh characteristic is metadata. Many variables in the database are computed from other variables in the operational databases. Real time or write time or active data. A data warehouse should be updated in almost real time, that is frequently, that is required in high transaction databases like high transaction volume industries or airlines, etc. Now let us see about different development strategies or development approaches for designing a data warehouse. That is data warehouse development approaches. There are basically two development approaches for data warehouse. That is bottom up and top down approach. So the bottom up approach is to produce smaller data marts which are needful for reporting needs of different departments or functions as needed. The second development approach is the top down approach. Now the top down approach is to make a comprehensive data warehouse that covers all the reporting needs of an enterprise. It provides consistency but takes more time and resources. Let us see the difference between the top down and bottom up approach, or comparing data mart with a data warehouse. Comparison of data mart and data warehouse. Now, this comparison is based on different domains like the scope of comparison, the value, the target organization, the time, the cost, the size, etc. Now let us see the difference between data mart and data warehouse. Okay, the first difference is a data mart is decentralized or it has a decentralized management, whereas a data warehouse has a centralized management. Means a data warehouse has a system that controls and coordinates the activities of data warehouse centrally, whereas data mart has a decentralized management, that is, it is distributed. The second difference is about the scope of the data mart. So the data mart is one subject or functional area, whereas a data warehouse is based on complete enterprise data needs. The third difference is the time required to construct data mart and data warehouse. So a data mart requires less time to construct, whereas a data warehouse requires more time compared to data mart to construct. Yes, a data warehouse needs more time compared to data mart to construct. The fourth difference is the cost of construction. So less cost is required to construct a data mart, whereas a data warehouse requires higher cost compared to data mart. The fifth difference is the approach used. The data mart uses a bottom-up approach, whereas a data warehouse uses the top-down approach. Next, we will see about the architecture of data warehouse or data warehouse architecture. The architecture of data warehouse has four key elements. The first key element is the data source. Second key element is the process of transformation. The third key element is data mart or the data warehouse, and the last key element is user applications. Okay, let us draw these architecture first. Now, that is a model. The first key element is data source. Now, what exactly is data source? The source from where the data warehouse can be constructed. Now, this can be created from structured sources or maybe unstructured or maybe semi-structured. The second key element is data transformation. What is data transformation? It is about ETL. What is ETL? Extract, transform, and load process. The third element is the data warehouse design or data mart or data warehouse. Now, data warehouse can be designed by using basically three different schema like star schema, snowflake schema and fact constellation, but we are discussing only about star schema here, that too in brief. The fourth key element is data warehouse access. The primary use of data warehouse is to produce management and monitoring reports. This can be done by OLAP, that is online analytical processing, or the dashboard view that can be helpful for the user to access the analysis result of the data, or OLTP, online analytical processing. Sorry, online transactional processing. Now, what are the different sources of data for construction of a data warehouse? This can be operational source or maybe external source. The operational sources are the operational sources are the enterprise system or ERP system or the legacy system, the point of scale, RFID, web usage, sensors, or any other source that generates the data in a particular format are the operational sources. And coming to the external sources, it can be the data that is generated by the suppliers or the customers or the governmental organization or etc. The second key element is data transformation. As I said, data transformation is nothing but the process of ETL. What is ETL? Extract, transform, and load. The data should be extracted from the operational or transactional databases or relational DBMS or from other application as well. The extracted data should be aligned together by key fields and integrated into a single data set. This transformed data should be uploaded into the data warehouse. That is the process of transformation. That is select, extract, clean, compute, integrate, and load data. These are the different phases in data transformation: select, extract, clean, compute, integrate, and load data. The third component is data mart or data warehouse, nothing but designing a data warehouse. As I said, so basically there are three schemas. There are three schemas for designing a data warehouse. That is star schema, snowflake schema, and fact constellation. But we are concentrating only on star schema here. So the star schema is the preferred architecture for the most of the data warehouse. Now all this schema are represented by using multidimensional data model. Means it has different dimensions. Each dimension represent a different value or the attribute. The last key element is accessing users and applications. Now, this can be done by using different OLAP tool, online analytical processing tool. So there are different OLAP tools available in the internet. We can use any of the tool for accessing and reporting. And we can make use of different reporting tools like Veka, R-Tool, etc. As well as different visualization tools like a dashboard, etc. As well as it is possible to make use of mobile devices to represent these analyzed data. The next topic is data warehouse design. As I said, a data warehouse can be designed in basically three different schemas, that is star schema, snowflake schema, and fact constellation. But we are discussing only about star schema. Now, what exactly is star schema? Star schema is commonly used model to represent a data warehouse. Commonly used. So most of the representation of a warehouse can be done by using star schema. Now it is a preferred data architecture for the most data warehouses. Now the star schema has a central fact table that provides most of the information of interest. So it has a large central table which is called as the fact table. Which is called as a fact table that consists of only key elements of other tables or the key information. Now this fact table that is placed centrally and is surrounded by different lookup tables. So one thing should keep in mind is the fact table should doesn't have any duplicates or redundancies. Now this fact table is surrounded by several smaller table which is called as dimensional table, or it is also called as lookup tables, which provides a detailed values. So several smaller table called as a dimensional table is placed around the fact table. Now let us see how to design this particular star schema. So there will be a central fact table. Now this is what actually the fact table is. Now this fact table doesn't have any duplicates. Now the interest in the fact table are the key elements or the key information of the dimensional table that is surrounded by. And this is the dimensional table. The rectangular box that I am drawing right now is the dimensional table. Now in this example, I am going to create 4-dimensional table which surrounds a single fact table. Now this dimensional table will give you about, or it gives a detailed description about related information about data. It requires much time to draw. I will share everything in the notes about the exact example given. That is what actually. So dt represents a dimensional table. That is the example for a star schema. Now this star schema doesn't have enough information because we need to write exactly what are the information that is present in the fact table as well as the dimension table. Okay, let us end this session. Let us do this session.